now let's start to answer the problem. Okay, before answer the problem, guys, let me to remind you some very important equations about the work we take before. Okay, let me to remind you some very important formulas or equations we take before. We take that the work or the net work equals F net times D. Okay, and if we have theta, we will say that cosine theta. Okay, but I will write it because it will be easier for you to remember. Net work equals net force times D. Anyone have a problem, guys? Of course, W here, this work, F net force exerted on the object, D displacement. That's very clear. Okay, now what about the kinetic friction? Kinetic friction equals mu k, the coefficient of frictions, times the Fn, times Fn. And Fn here, that is the normal force exerted perpendicular to the object's motion, and it equals most of time mg. Okay, mg. M, this is the mass, g, that is the acceleration. Okay, this equation is very important to remember to use it now here. Okay, guys, and of course, the work equals delta ke. It means work net equals KEF negative KEI. Okay, and we take, of course, KE, kinetic energy, equals half mv squared. Okay, that is all equations we take it before, and you should to remember all of these equations very well to explain this problem now. Okay, Shaf, now let's complete to explain this problem. I want someone to read, please, guys. I want someone to read this problem, please. Okay,
Can I read?
Yes, Abdurrahman, تفضل حبيبي.
Yes.
Yes.
On a frozen pond, a person kicks 10 kilogram.
Okay, stop, please. Okay, guys, now let's write the given. Here he give you the mass. Okay, mass here is 10 kilogram. Okay, 10 kilogram. Yes, complete, please.
Yes. Slip giving it an initial speed of 2.2 meter per second.
Okay, now he give you VI. This is the initial speed is 2.2 meter per second. Yes, complete. How far?
Yes. How far does the sled move in the coefficient of kinetic friction between the sled and the ice is 0.10.
Excellent. Now he wants D. He wants D. Okay, and he gave you the coefficient of friction mu k equals 0.1 without any unit for coefficient of friction, guys. Don't forget that. Okay, now in this case, now how far does the sled move? It means this sled will stop at the end. VF 0. This sled will stop at the end. How far does the sled move? If we have coefficient of friction, it means we have friction, we have a lot of things, and you push this sled, and this will stop at the end because that VF in this case equals 0. Okay, that is the givens, guys. Okay, now he give you m, he give you initial velocity or initial speed, and final speed is 0, and coefficient of friction 0.1. Okay, let's open the board to explain this problem. Okay, guys, now let's open the board. Sorry, just a minute. Now for this problem, guys, you should understand at the beginning. Now the work net, we said that before. Let me to erase all of these to explain again very clear. Okay, we said that work net equals delta ke, change in kinetic energy. That is the work kinetic energy theorem. Work net, as you see here, equals F net D. Okay, equals KEF times KEI. Okay, guys, now in this case F net here equals FK, kinetic friction. Why? Because that is the force will exert in this object. Most of time you will use the force he give you in the problem. Sometimes he will give you more than one force. Okay, you will make negative or positive or like that. But in this case, he gave you just the kinetic friction and talk about kinetic friction. It means that is the force exerted in this object, just this force. Okay.
Just only this force?
Yes,
like
only
FK?
this force exerted in this object to leave this object to stop. Okay. Now this the kinetic energy here, FKD equals half mv f squared times half mvi squared. Anyway, let's complete. Now Fk, we said that Fk equals mu k Fn or mu k mg. Okay, mu k mg d. Okay, d equals this one is 0. All of this 0. Why? Because Vf 0 here. This Vf here 0. Why? Because Vf at the end 0, and all of this equals 0. Okay. I'm sorry guys, this not times, this here negative. This one here negative, because this delta, it means negative. Okay, and now we have negative half meter vi squared. Okay, half mvi squared. Okay, look over here guys, the work at the beginning will become negative. Why negative? Because the object slowed down. Okay, now I think all things clear now. He wants d. You have mu k, you have m, you have g, you have mvi, you have all of things. You just find the d. Very simple. Okay, now let's complete with another color. Mu k 0.1 times 10 times 9.8 times d equals, we have a negative here, negative there, half 10 vi squared 2.2 squared. Don't forget the square, please. Okay, now we can say that here he wants d. Okay, we can say that here 0.1, it means 1 divided by 10. This cancel with each other, and this negative with this negative. Half with 10 equals 5. Okay, at the end it will be like that. D equals 5 times 2.2 squared divided by 9.8 equals at the end approximately 2.5 meters. Okay, just that. Anyone have? Okay guys, at the beginning we have many forms of energy. We can say that the work kind of energy, okay, but because all of them measured by joule, okay. Now let's talk about the potential energy. Okay, let's move for this one. We take all of them. Okay, yes. Okay, now suppose that we have very huge rock, as you see here, and this rock imbalance. Okay, and of course this work stay at the same place, but suppose that this rock start to move down because of the gravity, of course. Okay, now this rock change the position from here to the surface of the earth. Now this object move. From where this object come? The movement come from the energy stored in this object. This energy stored in this object is called potential energy. BE, it means potential energy. Okay, or potential energy. This potential energy stored in the object because of the position. Okay, and now look over here for another picture. Now this girl hold the ball. If this girl release the ball will moves down. Why moves down? Because we have energy stored in this ball. Come from the position of this ball. Okay, because that when she releases the ball will moves down like that, and that is called potential energy. The energy stored in the object because of its position. okay, energy stored in the object because of this because of the position. Okay, now it means what, guys? Also it means if you have ball, okay, and I will start to release the ball up like that. Now in fact I stored energy more in the ball. When I release the ball up more, when I lift the ball up more, now I store more potential energy. And like that, guys. Okay, that's at the beginning, that is the potential energy. Okay, now let's read the definition of the potential energy. At the beginning, guys, the potential energy, we have many forms of potential energy. We have many forms of potential energy. Potential energy comes because of the position, as you see here, this ball up from this mountain, for example. Now this one, because of the gravitational force, now we have potential energy inside this one. We have potential energy inside this rubber band. Okay, we have potential energy here called elastic potential energy. We have chemical energy. This chemical energy get out electric energy. Okay, now all of these many forms of potential energy, even the food you eat, the food, we have potential energy inside the food, because when you eat you will play, you have energy. From where you get this energy? From the food. Now we have potential energy inside the food. And like that, guys, we have many forms of the potential energy.
And then I guess if you potential energy,
guys, more about that. Okay, I want someone to read, please, guys. Let me to choose someone. Okay, Ibrahim Khalid. Ibrahim, excuse me, Ibrahim. Excuse me, Ibrahim Khalid.
Shape.
Yes.
Or condition of the object.
Yes, okay, guys. Now, this is the potential energy. That's energy associated with the object case or with the object position. Now, from where this object gets this potential energy? Maybe because of the position, maybe because of the shape, maybe because of the relationship between the object and the environment, maybe because of the chemical inside this object, like that. Okay, the relationship between object and the environment outside, or the interaction between the object and the environment outside, that is the potential energy. Okay, now we can see that the potential energy, we have many forms, as I told for you. Now let's talk with the first form and a very important form of potential energy, that is the potential energy come from the gravity, the gravitational potential energy. Okay, now as you see here, potential energy or gravitational potential energy, that is energy stored in the object because of the gravitational force or the gravitational fields. Okay, now that is the gravitational potential energy. Now any object higher than the Earth surface have potential energy. Any object. Okay,
gravitational بقى يا مستر.
Any object higher than the Earth surface have gravitational potential energy. And that is our session today to explain it, and we complete the problem about that, inshallah, next session with another form of potential energy. Okay, now we have some notes about that. Now gravitational potential energy, we will make symbol for that is BeG. It means gravitational potential energy. What is the unit of potential energy, guys? Anyone know? Open your microphone and answer, no problem. The unit. Joule, excellent. Okay, like all energy forms, guys, like kinetic energy, like work, all of them measured by joule. Okay, all of them measured by joule. As you see here, potential energy equals mgh. What is m? What is g? What is h? Let's ask someone, guys. Okay, Abdurrahman Abdulazim, do you hear me, Abdurrahman? Yes, Habibi. Now answer, please. Now what is m, guys? Now it means the height, the position of the object from the Earth's surface. Okay, as you see here, guys, from this equation you can see that the what is this gravitational acceleration depends on. I mean potential gravitational acceleration depends on the height. Okay, when we have more higher than the gravitational surface, or the Earth's surface, sorry, okay, now we have more potential energy, more potential energy, and also the gravitational acceleration, because maybe we are speaking about the moon. We are speaking about the moon. Of course, the gravity of the moon, not like the gravity of the Earth, like that. Okay, now the potential, just a minute, I'm sorry. Now the potential energy or the gravitational potential energy depends on two things: gravity or gravitational acceleration and the height. Question. Now, as you see here, the potential energy depends on the I speak about potential gravitational potential energy depends on the gravity and the height. Okay, and by the way, in general, guys, نعم يا عبد الله اتفضل. Gravitational potential energy, that is the form from potential energy. Potential energy, we have many forms. We have many forms. Can you see that here at the beginning? Because of the position, shape, condition of object, like that. All of these are types of potential energy, or the forms of potential energy. One of these form of potential energy is gravitational potential energy. Okay? Okay, guys, now, by the way, potential energy also depends on the object properties. The object properties. We are talking about what? We are talking about the elastic object. We are talking about the flexible ball. We are talking about the rock. We are talking about the properties of the object itself. This is a very important point. Exert or will exert on the potential energy. Okay. Anyways, let's talk about the last thing in the gravitational energy. We said that gravitational potential energy depends on the height. The height should to be from the zero level. What the meaning of from the zero level? What does it mean? It means that, guys, if we have ball like that, okay, and the height from this surface is 2 meters, for example, okay. Now, where is the zero level? This is the zero level, guys. This is the zero level. Okay, what does it mean? It means the potential energy in this case, zero. Here we don't have potential energy. I will change the color. Okay, now this is the zero level. It means the potential energy here, zero. Okay, now that is the height should to be from the zero level. Look over for this diagram here. Look over here. This is the zero level for this ball. This is the zero level for this ball, for here. Okay, if we throw the ball from here to there, that is the zero level of the height. Now we can measure the height from here to there. Okay, and like that, guys. Okay, now I have finished. I hope you understand.